Okay, so here's another graphical example of analyzing these polynomial characteristics. So we're going to first start with the sign of leading coefficient. Oh, before you get started, as you are drawing the sketch, notice that the y-axis is going by 5s. X-axis is going by 1s. So just make sure when we start labeling coordinate points down here, that's going to be helpful and make more sense to you when I start listing off numbers. Okay, so notice that when in your sketch. All right, so sign of leading coefficient. So remember, sign is positive or negative. That leading coefficient is the first term in the equation. Okay, so we always look to the right arrow to determine the sign. So since that right arrow is going down, the sign of the leading coefficient is negative. If it were going up, it would be positive. So just negative, not infinity. All right. Okay, so because of that right arrow. Now the degree of the polynomial is based upon the direction of both arrows, not just the right arrow. So if they're going the same direction, it's an even degree polynomial. Okay, when they're opposite like this, it's an odd degree polynomial. So think odd opposite. Okay, that might be a good way to remember it. So it's an odd degree polynomial. Okay, number of turning points, so literally where it turns, but another way to say it is when it goes from like decreasing to increasing or increasing to decreasing. So notice we have 1 here and 1 there. So number of turning points is 2. All right. Again, that can help us further analyze our degree because now we know the turning point, so we can always do number of turning points plus 1, and that's just if you're given the graph. You can't necessarily go the other way. If you have an equation, you can't necessarily determine the number of turning points or assume, but if you are looking at the graph, you can always look at your turning points and add 1. So this is actually a degree of 3, because 2 plus 1 is 3. Which represents an x to the third, or a cubic function, because that highest exponent is 3, so that's an x cubed, or x to the third, to be more specific there. Okay, your roots are your x-intercepts, your zeros, your solutions, all mean the same thing. So we have one right here where it crosses the x-axis, so negative 2, 0. Remember, your y value is always 0 for an x-intercept. We have one right here at 0, 0. And we have one over here at 1, 0. Okay. All right, your y-intercept is where it crosses the y-axis. So where it crosses the y is right there, also at 0, 0. That's not always going to happen, but just in these two examples, it just so happened that that's where it crosses the y-axis. Okay, so then your relative extrema, that's your high points and your low points, your mountains and your valleys. Okay, so looking here, we can see that we have a relative minimum, relative min, at right here, right? That's your lowest, or one of your low points. You're basically naming your turning points. Okay, so if I have 2 turning points, I have 2 relative extrema. That might be a way to kind of keep track. So relative min right here. I know it's a little bit, let's see, what is that? I don't know, negative 1.1-ish. You can be as specific as you want. That's probably close enough on that lovely graph. So negative 1.1 comma down here. So this is the part that might be confusing if you don't remember we're going by 5s. That's probably about negative 1, right? Negative 1, 2, 3, 4-ish. Okay, so we'll say negative 1.1 comma negative 1. And then we have a relative max, so a mountain or a high point is right here at what? 0.5 comma positive 1. That might be being a little high on that side, but I know, generally speaking. I'll give you prettier graphs than this when I ask you to label them. Okay, but that gets the gist right there. So there's your max, your relative max, and there's your relative min. All right, and then your multiplicity of zeros. So remember, you have to do this per 0. Okay, so we can say negative 2, 0 has a multiplicity of something. We can say 0, 0 has a multiplicity of something. Oh, wow, what did I do there? Okay, and then 1, 0 has a multiplicity of something. So we can take this bottom part out. All right, so negative 2, 0. So right here, you got to ask yourself, does it cross through, does it bounce, or does it bend? Okay, because that's multiplicity of 1, 2, and 3. So this one crosses straight through. It was above the x-axis, now it's below. So that's a multiplicity of 1. It looks like a linear function. Right, just like if you were to narrow your focus right around that x-intercept. Okay, 0, 0, right here. Does it cross? Does it bounce? Or does it bend? Well, that one crosses too. Okay, so notice it's underneath. It hits that point, and then it keeps going. Okay, so keeps going through. So that's a multiplicity of 1 as well. Don't know why that yellow thing is still there. There we go. Multiplicity of 1. And then over here, 1, 0, cross, bounce, bend through. This one crosses also. So notice it was above the x-axis, and now it goes through over here. So that has a multiplicity of 1. All right, let me put that in blue. Okay, so if it bounces and comes back down, that's a multiplicity of 2. Like a quadratic, and then if it bends, like snakes through, it's a multiplicity of 3, like a cubic function, or the parent function at least. All right, so in behavior, we start typing automatically as x approaches negative infinity. And again, use arrows for approaches and use your infinity signs if you're putting this in your journal. I just don't want to have to go find those tools. Okay, f of x approaches something. And then as x approaches positive infinity, f of x approaches something. All right, so as x approaches negative infinity, on the x-axis, your negatives are over here. So as we look to the left, what is that arrow approaching? Well, the y values are headed up, so they are headed to positive infinity. Cool. As x approaches positive infinity, so as we look to the right, f of x approaches, well, these y values are headed down forever and ever and ever to negative infinity. So you always have to analyze in behavior, the behavior at the ends, okay, at both ends. So you have to do both. You can't just do one. Infinity, and I cannot talk and spell at the same time. All right. Okay, so that's in behavior. Now let's knock out this lovely factored form basic equation. So remember, I say basic because we're not actually solving for that leading coefficient yet. So we just know that there's this a value in front. That's a transformation upon this function. There is, again, a way to do it, but right now we just want to get all the other characteristics based upon what we found here to put in our equation. Okay, we'll save that for later. All right, so always start with your roots, right? And remember, you got to switch the sign when they become factored form. I'm going to put that in blue so it stands out, hopefully. Okay, so we flip the sign, so x plus 2, x plus 0. Remember, with x plus 0, you don't have to write plus 0. You can just put an x in front. Because if you were to set just that equal to 0, x would be 0, right? X plus 2 equals 0. You'd have to solve, and you'd get negative 2, which we have here. And then positive 1 is a root, so we have to, in the parentheses, do x minus 1. And I'll try to get that bubble off so y'all can see that. Zoom in a little bit. That might be helpful to you. Just realized that. All right, so now we have our roots. Let's look at their multiplicities. So this one's kind of nice because, look, all their multiplicities are 1. So you could go ahead and put, if you wanted, to the first power. Okay, but totally not necessary because we look at that and know or assume that that's what it is if it's not written. Okay. So the multiplicity, we got that taken care of. The sign of leading coefficient. So this one's negative. So that means this value, this a value in front, has to be negative. Again, if you don't want to put that a there, then you just need to have a negative in front to represent that leading coefficient. And again, that's what that a value stands for, is negative. So that negative is super important. Okay. And then we can double check that our degree adds up based upon the multiplicities in our factors. So if we add up all the ones, 1 plus 1 plus 1 is 3. So we know we got that right. Okay. So again, that's just the quick, basic way of taking characteristics and writing that equation there. All right, so hopefully these characteristics are starting to click a little bit, and you are ready for your practice.